Hi everyone, I am Hemangi Karchalkar. So I'll be talking about OpenTofu, and this is a brief outline of what this talk is going to be about. So starting with OpenTofu. So what is OpenTofu? So anyone who has any idea of what is OpenTofu in the audience?
It's the Terraform.
Yeah.
Terraform changed their life.
Correct. So basically, OpenTofu is an open source infrastructure as a code tool. So what do you mean by infrastructure as a code tool? It treats all its infrastructure components like resources, networks, and servers as software components, which can be managed, developed, and deployed programmatically instead of managing them manually. It is community driven, and currently it is being managed by the Linux Foundation. And OpenTofu had its first release in January 2024. So you might say there are different open source infrastructure as a tool tools present in the market. So like if there is Terraform, then what is the need for OpenTofu? So in the year initially Terraform was introduced as an open source tool. However, suddenly in August 2023, Terraform changed its license from open source and suddenly transitioned to a non-open source license named BUSL. So while this license keeps the code as open source, but it imposes several restrictions on its usage. For example, we are not allowed to use it for commercial purposes now, and its future developments will be governed by commercial requirements, and corporates like a single company, HashiCorp, will be determining its future enhancements as per the customer needs. To keep the traditional Terraform alive, OpenTofu came into picture, and it is like a seamless replacement or a plugin for the traditional Terraforms. Okay, so we'll have a funky face off and about like why you should go for OpenTofu as opposed to Terraform. So first, like I mentioned, what gave birth to OpenTofu? The licensing limbo. With the sudden change of licensing from MPL, Mozilla Public License, to BUSL, which is a non-open source license, it left developers and everyone in the development community in a limbo. This is where OpenTofu stepped in and it embraced all the open source features and the community. Second, community collaboration. Even though Terraform has a very loyal fan base, but currently its interests are being directed by corporates, whereas OpenTofu stands for the community and it is by the community and everything is for the community. All the new features and fixes will be driven by community. Innovation and flexibility. Since OpenTofu is open source, so the community will lead its direction. Like wherever it will go, the community will be the one who will have a hold, not a certain company which will hold a monopoly. Fourth, technical similarities and the future diversions. So Terraform and OpenTofu 1.6 versions are completely compatible, and OpenTofu is completely backwards compatible with Terraform versions 1.6x up to 1.6x. But there onwards, there will be significant changes as well as conflicting changes. And secondly, like I said, open source versus corporate control. So since Terraform is maintained by HashiCorp with corporate interests guiding its direction, whereas OpenTofu is driven by community, so there is no single company or no single someone who is going to hold the monopoly. So audience, which side are you on? Do you want to explore Terraform, or do you are open to take the plunge and dive into the world of OpenTofu? Okay. So basically, OpenTofu has different components. So here, to define anything, we have a language known as Open Source Tofu Configuration Language. So this language is declarative. So any developers here, you might have heard about two terms. What is imperative programming and declarative programming? So in a nutshell, declarative programming focuses on outcomes rather than focusing on steps to reach the outcome. if you write an SQL query, it is a classic example of a declarative language. When you write select star from users, you just specify you want to retrieve all the users from the database, but you don't specify or tell the database engine how to go and retrieve all those users from the database. Whereas in imperative programming, what you do, you focus on the series of steps that you want to take. And example, there is a array and you have certain integers in it, and you want to append 2 to each of those numbers in that array. Here you will iterate through the loop. You don't just simply state the problem statement. You tell the program, you tell the computer how to achieve it. You iterate through the loop and add. So that is an example of imperative coding. So this language is declarative. That is, we'll simply define and declare that these are the 2 servers that we want to configure. This is an EC2 instance that we want to configure. How to do it, it is not your job. So this language, basically, the resources here in infrastructure terminology, the resources are the fundamental building blocks of an infrastructure. So to define these resources, you can use some OpenTofu configuration language. Also, these resources can be defined using JSON format. But for the purpose of this presentation, I have used OpenTofu configuration language. So these are the key components of OpenTofu language. I'll be discussing them one by one. So provider, resources, data source, output, variable, local, and provisioners. So providers, basically you define the provider to interact with infrastructure resources. So if you want to develop say if I want to host 3 servers on AWS and I want to do it via OpenTofu, so there has to be something that will interact with AWS. So this is where the provider comes in handy. It acts like a bridge. It acts like a mediator. So one hand, on my behalf, I'll ask the provider that I want to connect to AWS resources to create certain instances, and the provider will interact on my behalf. So this acts like a bridge. So it is also known as a plugin. So it not just interacts with some cloud providers, you also have the targeted platforms like Kubernetes or orchestration platforms. Secondly, resources. So resources are the fundamental building blocks of an infrastructure environment. So whenever we say resources, what we need to define is anything in an infrastructure environment is a resource. Your EC2 instance is a resource, your storage services are a resource, your networks are a resource. And together, this resource, the resource name and this resource type and the resource name should be a unique identifier in this entire hierarchy. And also this language, there are 2 basic things. Everything is a block and this provider is one block. How do you identify a block? A block starts with a keyword, in this case provider, and a curly brace. And wherever I have mentioned region and keyworded arguments, these are known as attributes. So blocks and attributes are the fundamental building blocks of this language. You have to define everything in a block. There is not a physical segregation as such blocks, but there is a logical segregation. And yeah, so here in the second example, firstly I am telling OpenTofu that I need to configure, I need to connect to AWS. So you need to download a plugin that will connect on your behalf to the AWS system. So this is where the provider steps in. In the second step, I'm specifying what exactly I want to create on the cloud. In this case, it is an AWS instance wherein I'm specifying the instance type and AMI image type ID is specified. Now coming to the workflow of OpenTofu. So basically, the OpenTofu workflow is divided into 5 major steps. Firstly, you write the code. This is where you open your code editors and you write the code. An OpenTofu file has an extension .tf. Since it is forked from Terraform, most of the Terraform people would say it is similar. Yeah, it is similar. It has an extension .tf. Secondly, you initialize the code. By initializing, what happens when I run tofu init command, this provider is downloaded from OpenTofu registry. This is act like a plugin. So this plugin is downloaded, and when I do, after you do an initialization, so you get a bridge to interact with the targeted systems, here in case AWS. In the third stage, you get to plan. Any architects, or if you're buying a building, you get to look at a plan, and then you decide you want to proceed or not. In the similar case, before building any infrastructure, say you want to host one S3 bucket and you want to host one EC2 instance, you will get a plan. The plan will actually list down all the resources that will be created or updated. So in the tofu plan command, you will get to, it will act as a review. So you will not end up, making some wrong things on the infrastructure or misplacing things. And the fourth step is you apply the plan. While applying plan means the plan is actually executed. Your resources are actually created on the infrastructure that you have selected. And the fifth step is destroy. All those things that you have created using OpenTofu will be completely destroyed. So let's say I have one S3 bucket on my AWS account, and I create 2 more S2 buckets using OpenTofu. And if I execute the tofu destroy command, will all buckets be destroyed, or only the ones which are created using OpenTofu? Anyone? Only the ones which are created, because the other one, there is no configuration. So how does OpenTofu keep a track of the configuration? It maintains some files known as state files, which we'll have a look later. Now if you look at the previous examples, you will see the AMI and the region, they were hard coded. This is not a best practice. For this, you need to define certain variables. These variables are defined in a file known as variable.tf. There is no hardcore restriction that you need to specify these files or have them in place, but you need to have a modular structure so that it is efficient for you to debug. Output blocks. Okay, now say you have created some infrastructure and servers, and I need the ID of the server that is created. So from where will it get? So this is where the output blocks come handy. They define the values that are exposed after the infrastructure is created. So the output block will get the ID of the instance that is created, or any infrastructure that you have created. Say public IPs are not available in case of EC2 instances. If you need the public IP, you will use this output block. And provisioners. Now say you have hosted an EC2 instance and you want to execute some or install certain scripts on that server, or you want to install Nginx server. So how do you do it? You don't need to manually log into AWS. This is where the provisioner part comes in handy. You can execute certain scripts even on the cloud and also on the local machine. You can execute. So these scripts can execute depending like where do you want them to take place. Data sources. So data sources is also one more important concept that we have in OpenTofu. You can get information about items which are external to OpenTofu using data sources. So yeah. Now actually how do we migrate from Terraform to OpenTofu? There is just one simple command, tofu we need to upgrade. But again, it is not as simple as it looks. We need to make sure that we have certain prerequisite steps in place. Firstly, we need to make sure that there are no pending plans in Terraform. Secondly, the Terraform version that we are using should not be greater than 1.6. Thirdly, if there are pending plan changes, you need to apply those changes to the infrastructure. Fourthly, take up a backup of the state files. In this case, if you take a backup of the state files, what will happen is you will, in case something goes wrong, you have the state files and you will be able to get your infrastructure back running into place. I'll have a demo of this later. Okay, so like I mentioned, information about your infrastructure is stored in files known as state files. So state files, they try to map the configuration that you have to your real world configuration. In the configuration, if you have mentioned, okay, I want to create an EC2 instance, and if it has been created, the state files will hold that information of what EC2 instance is created, the public IDs and the corresponding AMI IDs and all. So these state files, now these state files are by default stored locally. You're working as a team, you make certain changes to the infrastructure, your state file will be different and your colleague's state file will be different. This will create certain synchronization errors. So to avoid this, it is recommended to store your state files globally or remotely. So how do you store them? We store these files using a concept known as backends. So use just like everybody is using a version control like GitHub and all, so SVNs. So you have backends. So backends are used to store your state files. So there are two types of remote backends in this case. One is the standard backend and another is the remote operations backend. So in case of AWS, to store files, state files locally, you will be using S3 bucket and DynamoDB table. S3 acts like a storage and the DynamoDB table will perform the locking mechanism so that not two people are making changes to the same file at one time. That will prevent all the conflicts. So the standard backend just stores the tofu state files, but the remote operations backend not only just stores the state files, it stores the history, it stores the environment variables, it also stores the logs. So mostly like in production environments, you will need the remote operations backend. Now here are some important features. Like I asked you a question, if there are two S2 buckets that are created using my infrastructure as a code, and there is one S3 bucket that is already there. Now that is untracked because that is outside of that OpenTofu environment. So how do I make sure, like I want to control it programmatically. So how will I do that? This is where the import block comes into picture. You will be able to import some existing resources and import them into OpenTofu's configuration files. This is the syntax of it. It starts by the keyword import and the ID is the resource ID in the cloud. And with the to keyword, you will specify what variable should we assign. And when you execute a plan, it will generate the configuration code for that S3 bucket. In this way, that other S3 bucket or any resource which is outside of your OpenTofu configuration will be able to come into your configuration and you can control it programmatically. So these are some of the most advanced features that OpenTofu has. Say you want to create 3 VPCs and the code is same. So would you mind like writing the code every time? No, right? This is where you can use the count variable. And the for each variable also does the same thing. But there is a difference in count variable. If you are using a count variable with a list type, and if you delete some items from the list, your OpenTofu will recreate those resources in the infrastructure, which you don't want. You want the resources to be handled dynamically. You don't want the resources which are already being there to be created again. So in this case, you use your for each statement. And also there are other ternary operators. Also it comes with a powerful testing feature, which you can use using the tofu test command. So the tofu test command, firstly, it identifies where the test files are in your suite. Secondly, it provisions your infrastructure. Thirdly, it runs your assertions against the provision infrastructure. It forms an execution order. Certain scripts need to be executed beforehand. Certain scripts, like you need to upload the data in the database beforehand before checking it. So those things like get the security group first and then get the VPCs running and then attach them. So these depends on statements and validations are provided by OpenTofu. And lastly, it does a tear down. Just like in unit testing or PI testing, we have a setup and a tear down method. So it is like quite complex and it is very efficient. It can do it. So these are some of the OpenTofu best practices. Firstly, minimalize manual changes. Don't go and change any state files manually, even though you can do it. Like this is the most important thing that to be kept in mind. Secondly, modularize the code. Create different files like providers.tf will have information about providers. Your main.tf file will have information about resources. Your variables.tf will have information about the variables. create different files, modularize it. This is not the only structure, but this is like the generally accepted good practice. Utilize remote states. Utilize them so that you don't run into some state file errors or synchronization errors. If 2 or more people are making changes to the infrastructure, your state files may be compromised. So which is not what we want. Fourthly, use some version control. Fifth, use variables and outputs. The advantage of using variables and outputs is you can mask your sensitive information. If you don't want to expose some of your subnets or any IP addresses or any private keys, you can mask them in the plan explicitly, and also leverage loops and conditionals. This entire principle runs on dry, don't repeat yourself. So for that, you have to use these features that are provided by OpenTofu. Here are certain use cases of OpenTofu. They can be used to set up even some platform as a service applications. They can be used for the deployment, orchestration, management of Kubernetes or some orchestration platforms. It can be used for multi-cloud deployment. You can't have there can be multiple providers, so you can manage multiple clouds as well. It is used for it can be easily integrated into CI/CD pipelines. So it can seamlessly be integrated. And fifthly, self-service clusters. So self-service clusters are one that can be managed automatically without any manual intervention. So they can be used in creation, deployment, or any changes of like updation. And I have a short quiz. Please everyone take your phones out. Or you can go to menti.com and use the code 34013226. Just hop on. Has everybody scanned? Okay, you can go to menti.com. MENTI, menti.com. And use the code 34013226. This is like the KBC's fastest finger first, so make sure you do it on time. Okay, I'll start. We have 32 players, 33. Look at your screens, your phone, you will get the questions. Correct. Last few questions.
I chose the wrong one. Let me do that one again.
Next time.
With my contacts, they were all.
Ah. Surprised because I didn't discuss this, but still people got it right. And the last question.
Oh, dash U. Do you have a dash U on that?
Mm-hmm.
No? Okay. Got it.
Alan. Who is Alan?
Hey, all right.
Thank you. Thank you everyone, and special thanks to EPAM Systems. Please do visit our booth